Every planet in our solar system spins. That much we take for granted. The Earth beneath your feet is turning at this very moment, carrying you through day and night as it rotates on an axis tilted a gentle 23 degrees. Mars leans at a similar angle. Even mighty Jupiter spins nearly upright, like a top standing proudly on its point. But there is one world, far out in the cold and the dark, that does not behave like the others at all. There is one planet that lies on its side. Its name is Uranus, and it is tilted at a staggering 98 degrees, almost a full right angle. It does not spin upright like its neighbors. Instead, it rolls through its orbit like a ball knocked over and left rolling across a floor, its poles pointing not up and down, but nearly straight at the sun and straight away from it. No other major planet comes close to this strange posture. It is, quite literally, the planet that fell over. Try to picture it for a moment. Imagine spinning a globe on your desk, upright and orderly, and then imagine tipping it over until it lies flat, still turning, but now on its side. That is the reality of an entire world, 4 times wider than Earth, drifting through space in a position that seems to defy every rule its siblings obey. It is an image that, once you truly see it, is difficult to forget. And a posture that strange demands an explanation. Planets do not simply choose to lie down. Something must have happened, something ancient and violent, an event so powerful that it left this world permanently altered, still bearing the scar of whatever struck it billions of years ago. The tilt is not merely a curiosity, it is a clue, a piece of evidence pointing back to one of the most dramatic moments in the history of our solar system. So what could possibly knock an entire planet onto its side? To answer that, we have to travel back nearly 4.5 billion years, to a time when the solar system was a far more dangerous place than it is today. The early solar system was not the calm, orderly place we see through our telescopes now. It was chaos. It was a shooting gallery of rock and ice, of forming worlds crashing into one another, of debris the size of continents hurtling through space. Planets did not gently settle into place. They were battered, reshaped, and sometimes nearly destroyed in collisions of almost unimaginable force. And it is here, in this violent nursery, that scientists believe the mystery of Uranus was born. The leading theory is both simple and staggering. At some point in its distant youth, Uranus was struck by an enormous object, a protoplanet perhaps as large as the Earth itself, possibly even larger. The impact would have released energy beyond anything the human mind can properly grasp. And rather than shattering the planet completely, this colossal blow did something almost stranger. It tipped the entire world over, knocking it from an upright spin into the sideways roll we observe today. Consider the scale of that event. To move a planet, to physically rearrange the axis of a world tens of thousands of kilometers across, requires a force that dwarfs every earthquake, every eruption, every storm our own planet has ever known, all combined and multiplied many times over. This was not a nudge. This was a catastrophe written into the very bones of a world, one whose evidence still stares back at us across 4.5 billion years of silence. Some scientists suspect it may not have been a single strike at all, but perhaps 2 or more impacts over time, or the slow gravitational tug of a long-lost moon. The debate continues because we cannot go back and watch it happen. But the sideways tilt remains, an undeniable fact demanding a violent cause. Whatever struck Uranus changed it forever, and left behind a world that would go on to experience time and seasons in a way no other planet ever would. That violent tilt did more than change how Uranus looks. It reshaped how the planet experiences warmth, light, and cold itself. And that leads us to a puzzle that has genuinely baffled scientists, because Uranus is colder than it has any right to be. There is a rule that feels like simple common sense. The closer you sit to a fire, the warmer you are. Move away and the cold creeps in. It holds true on Earth, and it holds true across the solar system, where the inner planets bake under the sun and the outer worlds freeze in the distant dark. By that logic, Uranus, which orbits closer to the sun than Neptune, should be the warmer of the two. And yet, it is not. Uranus is colder. This is not a small difference to be brushed aside. The lowest temperature ever recorded in the atmosphere of Uranus plunges to around minus 224 degrees Celsius, making it the coldest planetary atmosphere in the entire solar system. Neptune, sitting far beyond it, roughly 1.5 billion kilometers farther from the Sun, is actually slightly warmer. By every rule we thought we understood, this should not be possible. And that is exactly what makes it a genuine mystery. So what is going on? The answer, scientists believe, may once again trace back to that ancient collision. Most planets, including the Earth, radiate their own internal heat, warmth left over from their formation, still leaking slowly out from deep within. Neptune does this powerfully, glowing with far more heat than it receives from the distant sun. But Uranus gives off almost no internal heat at all. It is as though something long ago shut off its inner furnace or buried it too deep to escape. The most compelling idea is that the great impact which tipped the planet over may also have knocked out much of its primordial heat, or that its strange internal structure traps the warmth far below, unable to rise. Whatever the true cause, the result is a world that defies the simplest law of all, that closer to the fire means warmer. Uranus sits nearer the sun than its neighbor, and yet remains the coldest place we know. It is a quiet reminder that the universe does not always follow the rules we expect. This extreme cold is only part of how strangely Uranus experiences its place in the heavens, because that same sideways tilt gives rise to something even more astonishing: seasons unlike anything a human being could ever endure. Here on Earth, the seasons are gentle companions. Spring softens into summer, autumn cools into winter, and the whole cycle turns in a single year, familiar and reassuring. We measure our lives by them. But on a world lying on its side, the seasons become something else entirely, something vast and slow and almost impossible to imagine from the comfort of our temperate planet. Because Uranus is tipped so far over, and because it takes 84 Earth years to complete a single orbit around the Sun, each of its seasons stretches on for roughly 21 years. 21 years of spring, 21 years of summer. And during that long summer, one pole of the planet is aimed almost directly at the Sun, bathed in continuous daylight for more than 4 decades, while the opposite pole is plunged into an unbroken night of the same staggering length. Sit with that thought for a moment, especially those of us who have lived long enough to measure time in decades. Imagine being born into darkness and living your entire childhood, your youth, even much of your adult life, before the sun finally rose over your part of that world. Imagine a night that lasts more than 40 years. On Uranus, this is not fantasy. It is simply the calendar turning at a pace no human heart was ever built to feel. This slow sideways dance creates conditions found nowhere else. When the sun finally does return to a frozen pole after its long absence, it triggers changes in the atmosphere, stirring the planet from its stillness. There is a strange poetry in it, a world where a single season outlasts a human career, where dawn arrives so rarely that generations could pass in the waiting. It reminds us how small our sense of time truly is against the great clock of the cosmos. A world this strange, this cold, this slow, hides its details well. And for the longest time, one of its quietest secrets went completely unnoticed, hidden in plain sight until astronomers happened to look at exactly the right moment. When we picture a ringed planet, one image rises instantly to mind: Saturn, wearing its brilliant, dazzling bands like a crown for all to see. For a long time, we believed Saturn was unique, the only planet adorned in such a way. Uranus, by contrast, seemed a plain and featureless ball, a pale disk in the distance with nothing remarkable about its edges. That assumption, like so many others about this planet, turned out to be wrong. In 1977, astronomers were watching Uranus pass in front of a distant star, hoping to learn about its atmosphere by studying how the starlight dimmed. But something unexpected happened. Before the planet itself reached the star's light flickered, blinked out briefly several times, then did the same again after the planet had passed. Something invisible was there, circling Uranus, blocking the light in a repeating pattern. The planet had rings, and no one had known. These are not the bright, icy bands of Saturn. The rings of Uranus are dark, some of the darkest material in the solar system, so black that they reflect almost no light at all, which is precisely why they had gone unseen for so long. Made of large chunks of dark rock and ice, rather than fine bright dust, they are narrow, faint and shadowy, a subtle circlet around a subtle world, revealed only by the chance alignment of a distant star. There is a lesson hidden in that discovery, one worth pausing on. For centuries we had looked at Uranus and assumed we understood it, assumed there was nothing more to see. And all along, encircling the planet, was an entire ring system waiting patiently to be noticed. It is a humbling reminder that even in our own solar system, even in places we believed we knew, wonders can hide in plain sight, needing only that we finally look closely enough. If something as substantial as a ring system could stay hidden for so long, what else about this planet had we failed to truly see? Even something as simple as its color turns out to hold a mystery of its own. Look at a photograph of Uranus, and one thing settles over you almost immediately: a sense of calm. Where Jupiter rages with storms and stripes, and Saturn glows in warm shades of gold, Uranus appears smooth and serene, wrapped in a soft pale blue-green, like a marble of frosted sea glass suspended in the dark. It is one of the most quietly beautiful sights in the solar system. But where does that unusual color come from? The answer lies in the planet's atmosphere, and in a gas that most of us know from a very different context. The upper atmosphere of Uranus is rich in methane. As sunlight, which contains every color, streams in and strikes this methane, the gas absorbs the red portions of that light, swallowing them, holding them back. What remains, what is scattered and reflected back out into space for our telescopes to catch, is the blue and green. And so, the planet wears the color of what its atmosphere chose to reject. It is a strange and rather beautiful idea when you think about it. The color we see is not truly the planet's own. It is the leftover light, the portion of the sun's rays that the methane did not keep. In a sense, we are looking at an absence, the shadow of red, painted across an entire world. Something as ordinary as a gas, the same methane found in swamps and pipelines here on Earth, becomes, on Uranus, the painter of one of the loveliest colors in the heavens. And yet even here, the planet keeps a secret. Its neighbor Neptune contains a similar amount of methane, and yet appears a deeper, richer blue, while Uranus remains paler and more muted. Scientists now believe a layer of haze, a kind of atmospheric mist, sits over Uranus and washes out its color, softening it. Even in something as simple as a color, this world refuses to be fully explained, holding back just a little more than it reveals. The planet itself guards its mysteries closely. But orbiting this pale, silent world is a family of moons, and their story takes us in an entirely unexpected direction, away from cold science and toward the world of poetry. The other planets carry moons named from the myths of ancient Greece and Rome, gods and heroes and titans, names heavy with thunder and war. Jupiter has its Io and Europa and Ganymede. But when it came time to name the moons of Uranus, someone made a different and rather beautiful choice. Instead of reaching for the old gods, they reached for the poets. They reached for Shakespeare. The moons of Uranus bear the names of characters drawn from the plays of William Shakespeare and from the poetry of Alexander Pope. There is Titania and Oberon, the queen and king of the fairies from A Midsummer Night's Dream. There is Miranda and Ariel from The Tempest, and Puck, the mischievous sprite. There is Ophelia and Desdemona, Juliet and Portia. Circling this distant, frozen planet is a company of characters born not from mythology, but from the human imagination at its most tender and profound. There is something deeply moving in that decision, especially for those who love language and story. On the coldest, most remote major planet we know, a place of violence and darkness and 40-year nights, we chose to hang the names of love, jealousy, magic, and dreams. We took the warmth of human art and carried it out into the farthest reaches of what we could touch, as if to say that even there, in the silence, poetry belongs. It is a reminder that science and art are not the enemies they are sometimes made out to be. The same species that calculates the orbit of a moon down to the second also chooses to name that moon after a fairy queen. We are creatures of both reason and wonder, of both mathematics and metaphor. And nowhere is that union clearer than in this quiet family of Shakespearean worlds, turning slowly around a planet that lies on its side. But one of these moons is far stranger than the rest. Among all these poetically named worlds, one small moon stands apart, not for its name, but for its face. When our one and only spacecraft finally photographed it, what it revealed was one of the most bizarre landscapes ever seen by human eyes. Miranda is small, barely 500 kilometers across, a modest little moon that by all reasonable expectations should have been dull. Small moons are supposed to be simple. They are meant to be quiet balls of ice and rock, their surfaces smoothed by time, unremarkable and still. That is what scientists expected to find when the images of Miranda first came back. What they saw instead left them stunned. Miranda's surface is a chaotic, broken patchwork nightmare of terrain, unlike anything else in the solar system. It is a jumbled collage of jagged ridges, deep grooves, and mismatched regions that look as though they were torn apart and clumsily reassembled by a careless hand. Ancient cratered plains sit jammed against strange, twisted formations, with no smooth transition between them, as if several completely different worlds had been shattered and fused into one small, tortured moon. And then there are the cliffs. Miranda is home to a towering scarp known as Verona Roup, believed to be the tallest cliff in the entire solar system. It plunges downward for as much as 20 kilometers, a sheer drop many times deeper than the Grand Canyon, taller than any precipice on Earth by an enormous margin. Because Miranda's gravity is so weak, an object falling from the top of that cliff would take several minutes to reach the bottom, drifting down through the darkness in an eerie, endless-seeming fall. How did such a small moon become so violently scarred? Scientists still debate it. Some believe Miranda was once shattered by a massive impact and then slowly pulled back together by its own gravity, its pieces never quite settling into order. Others suspect internal heating stirred and cracked its surface long ago. The truth remains uncertain, another open question in a system full of them, written across the face of the strangest little world we have ever photographed. Everything we know about Miranda, about the rings, about those poetically named moons, came to us from a single visit. Just one. In all of human history, only one spacecraft has ever traveled close enough to see Uranus with its own eyes. Think of how much we have said about Uranus, its tilt, its cold, its rings, its moons, the shattered face of Miranda. Now consider a humbling truth behind all of it. Nearly everything we know, the close-up images, the detailed measurements, the discoveries that reshaped our understanding, came from a single spacecraft during a single fleeting encounter that has never once been repeated. That spacecraft was Voyager 2, launched from Earth in 1977, the same year those hidden rings were discovered. After years of travel across the solar system, It reached Uranus in January of 1986, becoming the first, and to this day, the only spacecraft ever to visit. It did not stop. It could not stop. It swept past the planet at tremendous speed, gathering as much data as it possibly could in the brief window it had, and then it was gone, carried onward into the dark toward Neptune and beyond. The entire close encounter, the heart of it, lasted only about 6 hours. 6 hours. After traveling billions of kilometers over nearly 9 years, our single greatest look at this world amounted to less than a single day. In those precious hours, Voyager 2 discovered new moons, revealed additional rings, measured the strange tilted magnetic field, and captured the images of Miranda that stunned the world. Almost everything in our textbooks about Uranus was gathered in that one short pass. There is something both triumphant and melancholy in that. Triumphant because a machine built by human hands traveled so impossibly far and taught us so much in so little time. Melancholy because it means our knowledge of an entire planet rests on a glance, a single afternoon's worth of data now decades old. Voyager 2 gave us a priceless gift and then vanished into interstellar space, leaving us with a portrait sketched in just 6 hours and a hunger to see more. Because that brief encounter, for all it gave us, also revealed how much we still do not understand. And the honest truth is that Uranus remains one of the greatest question marks in our entire solar system. It would be easy, after all these discoveries, to feel that we have Uranus figured out. But honesty demands otherwise. The truth is that Uranus may be the least understood major planet in our solar system, and the more closely you examine what we actually know, the more you realize how much remains stubbornly, genuinely unknown. We are not certain what lies beneath its clouds. Scientists believe Uranus may hide a vast ocean of exotic, superheated water, ammonia, and methane, a strange slushy layer sometimes called an icy mantle, but we have never seen it and cannot yet confirm it. We do not fully understand its bizarre, lopsided magnetic field, which is tilted and off-center in a way that makes little sense. We do not know for certain why it gives off so little heat, or exactly what happened during the collision that knocked it over. Even the number of its moons remains an open question. We know of at least 27, but smaller ones almost certainly wait undiscovered in the darkness. We cannot say with confidence how or when its rings formed, or how long they will last. For a world we have technically known about since 1781, when William Herschel first identified it as a planet, our ignorance is remarkable and strangely beautiful in its own way. There is no shame in admitting this. In fact, there is something deeply respectful in it, a refusal to pretend we know more than we do. Every one of these open questions is not a dead end, but a doorway, an invitation to look closer, to return, to finally give this distant world the attention it has waited so long to receive. And the good news is that scientists, at last, are beginning to answer that call. Because after decades of silence, a serious effort is now underway. An effort that could transform this pale, distant question mark into one of the best understood worlds we know. And it may happen within our lifetimes. For decades, Uranus sat quietly near the bottom of our list of priorities. The inner planets were closer and easier. Mars called to us with the promise of past life. Jupiter and Saturn dazzled with their moons and storms. And so Uranus waited, unvisited since that single afternoon in 1986, its mysteries left to gather dust. But recently, something has changed. The scientific community has begun to turn its gaze back toward this forgotten world. In recent years, an influential review of priorities by the planetary science community identified a dedicated mission to Uranus as one of the highest goals for the coming era of exploration. The concept, often referred to as a Uranus orbiter and probe, would not simply fly past as Voyager did. It would arrive and stay, settling into orbit for years, studying the planet, its rings and its strange moons in patient detail, and dropping a probe directly into the atmosphere to taste its secrets from within. Consider what such a mission could finally reveal. It could confirm whether that hidden ocean truly exists beneath the clouds. It could unravel the mystery of the tilted magnetic field, measure the planet's true internal heat, and study the seasons as they slowly turn. It could revisit Miranda and the other Shakespearean moons, this time not in a fleeting 6-hour glance, but over years of careful observation, answering questions we have carried for nearly 4 decades. There is a sobering reality to these missions, though, one that speaks directly to the passage of time. Because Uranus is so far away, such a journey would take many years simply to arrive, and years more to do its work. The people who launch it may well be gathering its greatest discoveries in their later years, or handing that joy to the generation that follows. To reach for Uranus is to plant a tree whose shade we may only partly live to enjoy, an act of patience and faith in the future. And that patience, that willingness to reach across decades toward a cold and distant world, points to something deeper. It points to the real reason any of this matters at all, not just to scientists, but to each of us. We might ask in the end why we should care about a pale, sideways world, so far away that its light takes nearly 3 hours to reach us, a place no human will ever walk, so cold and remote it can feel almost irrelevant to our daily lives. It is a fair question, and the answer reaches beyond science into something more human than data and measurement. Uranus matters because it humbles us, and because it reminds us how much wonder still remains. Here is a world in our own solar system, a neighbor in cosmic terms, and yet we have visited it only once, understood it only partly, and stand before it still full of questions. It tells us that discovery is not finished, that mystery has not been used up, that even close to home there are secrets patiently waiting. In an age when it can feel as though everything is already known, Uranus quietly insists otherwise. It matters too because of what it says about us. We are the species that looked at a faint dot lying on its side and refused to look away. We named its moons after our poets. We flung a machine across billions of kilometers for a single 6-hour glimpse. We are now planning to return, knowing some of us may not live to see the answers. That reaching, that refusal to stop wondering, is among the finest things about being human, and it does not fade with age. If anything, it deepens. If this journey through the mysteries of Uranus stirred something in you, if it made you pause and see the night sky a little differently, then I would ask you to do a few simple things. Subscribe to this channel so you do not miss the next journey we take together into the wonders of the cosmos. And if this video moved you, please take a moment to give it a like, because it genuinely helps others discover these stories as well. Most of all, I would love to hear from you. Leave a comment below and tell me, which mystery of Uranus struck you the most? Was it the ancient blow that knocked it sideways, the 40-year nights, the shattered face of Miranda, or the single spacecraft that visited just once and vanished into the dark? Your thoughts turn this from a video into a conversation, so keep looking up, keep asking questions, and keep letting yourself be amazed by a universe that has never once stopped being amazing. Thank you for spending this time here. I will see you on the next one.